All right, so let's talk about power series. First off, what is a power series? Well, a power series is a function. A power series is a function. It looks something like this. F of x is equal to the sum from n equals 0 to infinity of an, so just like a regular series, times x minus c raised to the nth power. And if we were to write down the individual terms in that sum, we'd see that we'll get something like a 0 times x minus c to the 0, which is just 1, plus a 1 times x minus c, plus a2 times x minus c squared, plus a3 times x minus c cubed, and so on. And you'll notice that you can think of this as being just an infinite degree polynomial. Right? It just has a bunch of powers of x minus c. And in terms of notation, we can call c the center point. Often we'll have c equal to 0. It'll make the formula a little bit nicer here. But sometimes you want to set up your power series relative to some other value of x. And so in the more general formulation, the power series has x minus c raised to an n. But notice, if you were to just FOIL that out, you would still see that you just have a bunch of powers of x's with constants. And then we have what's called the coefficient out front. And this depends on n. It could be a constant, it could be 1 over n, it could be 1 over n factorial, it could be a wide variety of different things. But what you'll notice is that for any particular value of x, if we plug in a number for x, this will look like, well, a regular old series. And so what we'll find is that whether this converges or diverges is going to depend on the value of x, because we'll get different series for each particular value of x. And so what we can talk about with a power series is where does it converge? What values of x will lead to convergence? And there are two terms that you should know about that. We have what's called the radius of convergence. And what you're going to find is that c, that center point, is going to be the middle of some interval on the number line. And so if we were to draw a number line, let's put up point c, what you're going to find is that this is going to converge between something like c minus r and c plus r. And so that distance from the center point out to the sides is what we would call our radius of convergence. And another way of writing that interval is that it will converge for values of x minus c that are less than r. All right, so this is completely equivalent to saying that x is between c plus r and c minus r. All right, so that's the radius of convergence. It tells us how far away from that center point can we go and still get convergence. Now, I'm assuming here that it does converge at the center point, and if that's not clear, let's take a look at our original series. What happens if we plug in x equals c here? Notice you get 0 to the n, so you're just summing up 0 over and over and over again for all of your terms. So a power series will always converge at that one particular point. The question is, does it converge elsewhere? And so you can have r equals 0, where it only converges at one point. You can also have r equals r being infinite, which would be where it converges everywhere. Or you can have a finite value of r, and that means it's going to converge on some interval. Which is centered at c with radius r. Okay, and again, we're calling it radius because you can go that direction, r units in either direction. So you could think of that as a one-dimensional circle centered at c. All right, so that's a radius of convergence. You can also talk about what's called the interval of convergence. And the interval of convergence is going to be just slightly more specific than knowing the radius. Assuming r is actually a finite number, the interval is going to take into account the endpoints as well and tell us, does it converge at c plus r? Does it converge at c minus r? And we'll see that sometimes the endpoint should be included in that interval, and sometimes not, and maybe sometimes one of the endpoints will be included in the interval. Okay, so that involves checking whether the endpoints, which are x equals c plus or minus r, lead to convergence. And typically when you compute the interval of convergence, you'll use square brackets, which mean including endpoints, or you'll use parentheses to exclude, or you can use some combination where you include one and exclude the other. All right, so let's do an example here. Let's see how we can actually compute the radius or interval of convergence for a particular power series. All right, and so we'll look at the sum from n equals 0 to infinity of x to the n over 2 to the n. Now, first thing I want to do is I want to see how this is actually in the form of a power series. And so what we'll do is first off, we will write this as a constant times x minus something to the n. And the question is, what does that constant need to be? And notice here, we had x to the n was multiplied by 1 over 2 to the n. So there's our an. And then in this case, we had just x to the n. So we can think of that as x minus 0 to the n, which means the center point is just 0. Okay? So this does fit in the template of the power series. And then the question is, where, which x values does this converge? Okay? Now, the way to check for convergence is to use some of your series tests. And for power series, the one you're usually going to want to start with is the ratio test. So step 1, we will apply the ratio test to find the radius. And then once we've got the radius, we will check the endpoints using some of our other tests. All right, so let's apply the ratio test here. Our terms in the series, I'll call them Bn. Bn is just x to the n over 2 to the n. And so b to the n plus 1 is equal to x to the n plus 1 over 2 to the n plus 1. And so if I want to apply the ratio test, I have to look at the limit as n goes to infinity of the absolute value of b to the n plus 1 over bn, which is the same thing as multiplying by the reciprocal of bn. Okay? And a couple of cancellations we can make there. Notice we have n plus 1 factors of x on top and n on the bottom. And so we can cancel those out, and we'll be left with just x on top. And with the 2's, we have n factors on top and n plus 1 on the bottom. So we can cancel all of those out, and we're going to be left with just a 2 on the bottom. And notice, at that point, we've canceled out all of the n's. And so we really don't need to write the limit anymore. Rho is equal to the absolute value of x over 2. And if we think back to our ratio test, the condition for convergence is that the ratio is less than 1. So this converges when x over 2 is less than 1. And if we do a little bit of algebra to rearrange that equation, we can now find our radius. Notice we could write that as absolute value of x over absolute value of 2. And absolute value of 2 is just 2. And if we multiply both sides by 2, we'll have absolute value of x is less than 2. And so there we go. Our radius of convergence is 2, and our center of convergence is, again, 0, as we noticed originally. So r equals 2, and so if we're to draw out a number line, so there's 0. If the absolute value of x is less than 2, then it means we're between 2 and negative 2. And we would say that if we are in that range, we have convergence. If we are outside that range, if absolute value of x over 2 is greater than 1, we have divergence. And same thing if it's less than negative 2. But precisely at the endpoints, at 2 and negative 2, that would be where rho is equal to 1, which was inconclusive. And so we still need to check the endpoints, 2 and negative 2. Do we get convergence there? Okay? And so what we'll do is we'll go back to our original series. Our series was the sum of x to the n over 2 to the n. So let me start with x equals 2. If I plug in 2, I get 2 to the n over 2 to the n, which is just the sum of 1. Well, that's not a very interesting series. That just adds up 1 over and over and over and over again. Well, that must diverge, right? But it fails the nth term test. The terms do not go to 0, so that one diverges. And so at 2, we would probably want to put parentheses there, indicating that we don't actually include 2 in the converges range. So it would diverge at x equals 2. And if you plug in negative 2, we'll have the sum from n equals 0 to infinity of negative 2 to the n over 2 to the n, which is the same thing as the sum of negative 1 to the n. And if you write down the terms in that, that will just give you negative 1 plus 1 when you plug in 0, minus 1, plus 1, minus 1, plus 1, minus 1. And we argued previously that that one diverges. It's not really approaching any particular value. All right, and so we would put parentheses at the other end as well. We would say that it diverges at x equals negative 2. So our interval of convergence would be from negative 2 to 2, excluding the endpoints. All right, we'll look at some more examples of these types of problems in the next video.